In this video, we are going to work on alternate forms of the Pythagorean theorem. I'm going to scroll up because I'm going to use my picture up here. We're going to focus on the Pythagorean theorem, and we're going to come up with some trig identities coming from. This will be like the number one identity I need you guys to memorize all semester. So first, let's take our triangle that we have here. This is the unit circle, radius of 1. And I know, let's start off, because we're going to use this, cosine of theta is going to be equal to x, right? X over 1. Sine of theta, given this triangle, is y over 1, right? Our normal definitions. I also know that on this right triangle I have in blue, that x squared plus y squared equals 1 squared. Well, then I can just replace. Okay, this looks like this, cosine theta squared plus sine theta squared equals 1. All right, well, we have to be careful that the way we write this. Don't write this down. This does not mean the whole thing squared like we wrote down here. That means square theta and then take the cosine of it, right? We want it to not equal that. So we can either write what I have written, or the way we write it in trig is we put the square right by the cosine like that. So sine squared theta plus sine squared theta equals 1. This is called the Pythagorean identity. This is the number one identity. If I had to choose out of all of them for you to memorize, it would be this one. That is the Pythagorean identity. And we actually get two more from it. It's an equality. I can do whatever I want. So take a look at this function over here. Notice that the beginning, the top, is cosine squared plus sine squared equals 1. That's the top. Well, we can actually get to two other identities if I just divide everything by cosine or divide everything by sine. So if I take all three sides there, all three parts, there are only two sides, all three parts, and I divide by cosine squared, what we get is, okay, well, this makes cosine squared over squared makes 1. Sine squared over cosine squared is tangent squared. That's the definition of tangent. And then 1 over cosine is secant. So you need to memorize this here that I have starred and highlighted, but to get to these two, or that one now first, and this other one that we're going to all explain now, all I have to do is divide like this. I don't have to memorize these two, right? I just need to memorize that one. And then I can divide by cosine to get my top equation, or I can divide by sine. So take a look at this one. I have cosine squared plus sine squared equals 1. And then we divided all parts by sine. Well, cosine over sine is cotangent. Sine over sine is 1. And 1 over sine squared is cosecant squared, because sine flipped over is cosecant. So to get those other two, you just need to divide. There's no reason to waste brain space with that. Memorize this. You have to. There's no way around it. Memorize that and get to the other two just with division. All right, let me do an example of how these could be helpful. We're going to use those mainly later to prove things. But as of right now, how they're useful is we can find the other 5 functions given some information. So they gave me that secant is negative 7 over 18. So when I do this before I start, I like to do, write them out. So let me do sine of t, cosine of t, tangent of t. The reason I do this is because I'm really good at doing one part of the problem and then moving on. I'm notorious for doing that. And then cotangent of t. They gave us secant is negative 17 over 8. That tells me that cosine is negative 8 over 17. A couple of ways I could go about this. I'm going to take the way using these theorems, but I also could take this ratio and just draw a triangle and fill in the parts, right? That gives me two sides, that gives me x over r, gives me x over r, and I can find y with the Pythagorean theorem. But instead, we're going to use the theorems that they were given to us. All right, so let's take, we're going to use the one that I memorized, and you are going to have it memorized if you don't already. Sine t plus cosine t, both of them squared, has to be equal to 1. And I'm going to plug in that cosine. So I get sine t squared plus, and it's going to be negative 8 over 17 squared equals 1. I'm going to solve for sine now. So I square that, I get 64 over 17, I think, 249 maybe. My brain's not working with arithmetic today like most days. 289. And that still equals 1. if I subtract that over, I do 289 minus 64, and I get 225 over 289. That's moving this over just by minusing. You can use your calculator if you'd like. I need to get rid of the square, so when I take the square root, anytime I take a square root, if you don't remember x squared equals 9 from algebra, if I take the square root of both sides, I get a plus or minus 3. I get both, right? So if I take the square root of top and bottom here, okay, I get 15 over 17, but I get what we call plus or minus, like algebra. But what we're going to look for is we know that it's 0 through pi. Okay, so if I think of my unit circle, 0 through pi, that's these two quadrants, 1 and 2. Sine is y, and in both these quadrants, it has to be positive. So I know sine of t is the positive 15 over 17. The reason I knew that is because this tells me it's in quadrant 1, right? And I looked in quadrant 1 and 2, quadrant 1 and 2, and y is positive in both of those. Sine is y. That allows me to find cosecant. So cosecant then would be 17 over 15. And now, to get my tangent, I can use my fundamental identity for tangent. Tangent of t is equal to sine of t over cosine of t. And I just plug them in. 15 over 17 divided by negative 8 over 17. But remember, fraction bars are just division. So we get 15 over 17 divided by negative 8 over 17. And I follow the arithmetic here. 15 over 17 times 17 over negative 8 is going to leave me with a negative 15 over 8. And then to get cotangent, all I got to do is flip it. So there we go. There's our 6 functions. This is why I like to write it in the beginning, because I know it's clear. Once I fill in all 6 spots, I am done. So these identities can get you out of these sticky spots without ever having to draw a triangle. The only thing that you're going to have to worry about is anytime you use these, you're going to do a square root. You'll get a plus or minus, but you just have to draw a picture and ask yourself, sine is y or x, or tangent is x and y, or cosine is x, right? I think I said sine is x, but sine is y. We can just break it down using our quadrants and using positive and negatives to figure out this plus or minus. Cool.